Now, I concisely overview the application of optimal power flow by using an example rated with a modified version of the IEEE 9-bus test system. In this lecture, we focus on shaping the theory with the practical implementation and use of the optimal power flow functionalities of Panda Power, which is an open-source Python-based tool for modeling, analysis, and optimization on electrical power systems. Like MathPower, Panda Power provides user-friendly data structures and built-in solvers, like for instance AC/DC optimal power flow using integer point methods, to determine optimal operating conditions of electrical networks under technical constraints and cost functions. A modified version of the IEEE 9-bus test system has been selected for illustrative purposes. The modifications concern with the addition of an offshore wind power plant with 180 megawatt installed capacity. The plant has an alternating current interconnection to bus 9 of the test system. The interconnection comprises two transformers and submarine cables. Besides, the total demand increases to 630 megawatt in active power and 230 MVAR in reactive power. The total generation capacity is 1000 megawatt. The data of the test system is structured in Panda Power. Note that this tool sorts the components starting from zero. Thus, for instance, bus number 1 shown in the diagram of the IEEE 9-bus test system is bus 0 in the matrix data of buses in Panda Power. The system data is given in an Excel file that is read by Panda Power. Hence, the data of the modified version of the IEEE bus system is included in the file name as IEEE 9 Wind XLX. You can change the data of the Excel file to ensure that Panda Power considers any desired modification. For instance, the Excel sheet named as Trafo contains the data related with transformers. For illustrative purposes, let's consider that the user wishes to change the location of the interconnection point of the wind power plant. This can be done by changing the index or bus number given in cell D5. In the example shown here, the interconnection point is changing to bus 7 of the IEEE bus test system, corresponding with number 6 in Panda Power. Recalling that this tool sorts the components starting from 0. The Excel sheet named as Gen contains the data related with power plants. The data of the cells D and E can be changed to define the active and reactive power outputs, whereas the minimum and maximum limits of these outputs can be set in cells G, H, M, and N. A desired active power dispatch can be enforced by defining equal values of minimum and maximum active power outputs in cells M and N. A desired reactive power dispatch can be enforced by defining equal values of minimum and output active power output in cells G and H. So, in the example shown here, the wind power plant has an active power output of 180 megawatt and a reactive power output of 0. Finally, the Python script named as IEEE Wind is used to import the data from Excel, whereas the function pp roundup pp is executed to perform optimal power flow calculation. The outcomes obtained from optimal power flow calculation can be summarized and depicted in tables or figures generated in Python. For instance, a bar plot is used to visualize the profile of bus voltage magnitudes across the system. Note in this example that the system has bus voltage magnitudes close to the nominal voltage, 1 per unit, and they are within the load 5% deviation. Additionally, the loading on the transmission lines and transformer is below 100%, indicated power transfers within the corresponding physical capacity limits. To sum up, in this video, you have learned how to use another open tool like Panda Power to structure a model of a power system for optimal power flow calculation and to process and interpret the obtained results. Thank you for watching.